We now want to go ahead and begin with the design entry using schematic capture. We're going to go to the File menu and choose New. From the New menu, we're going to look for the block diagram schematic file. Clicking on that and choosing OK brings up our grid-based system called Block 1 or Block 2. I happen to actually have one called Block 1. And so we have our BDF file being created. Now that we have this tab, we can go ahead and begin to create a new source file. Notice a few things about our windows that we have here within Quartus 2. Up here on the left, we have the Project Navigator. Notice as long as it's under the Hierarchy tab, we have the name of our project and we have the chip number that's given to us. It's a Cyclone 5 and there is our chip number. And then we can choose other tabs. We have Files, and as we add files to the project, they'll be listed here. There are other tabs as well. The two that we'll mostly focus on in this class will be the Files and the Hierarchy. Below the Project Navigator window is the Tasks window. Notice these windows can be closed, they can be moved or unpinned, and they can be minimized. Within the Task window can also be minimized and unpinned. We're going to choose, or we're given the choice of what we actually want to have executed once we've created some of the files. And then we also have the user interface window, which is large, which is here. At the bottom, we have the messages window. When we're compiling, if we have any errors or if we have success, all of those messages that are coming back within the compilation are posted down here in the message files. You can always expand this when you're trying to see what's happening or what has happened in the compilation. If you get errors, you probably will want to expand this, also using the up and down scroll bar over here on the right once you start getting some messages. But right now we're working in our BDF, our design file, and so we want to go ahead and begin to add some symbols. When we do that, notice that we can change some aspects of this window. If we wanted to increase it, we could go to View and we could zoom in or zoom out as necessary, allowing us to change if it were too small or too large. And later on, as we get more complex circuits, we may want to zoom in so that we can see the whole thing on one to get a screenshot. But for right now, let's go ahead and draw our circuit from last week. Looking at the symbol tools, we can come up here and click on the symbol tools. And notice there is a list of libraries. We're going to expand those libraries to find out the gates that we need. All of the gates that we need are listed in the primitives. And so we'll click on the primitives. And notice we also want to make a choice. Here we'll make a choice of logic. And within that logic, we see that there are lots and lots of choices. If we look at the AND 2, notice that looks like a basic AND gate with 2 inputs. If we were to choose the AND 4, again, another AND gate, but we have 4 inputs. We could also click on some of the other alternative AND gates. Notice the band 2 or the B AND 2 is basically an AND with inverted inputs. And so if we had some NOTs and we wanted to use something like the band 2, we could. But for right now, we're going to go ahead and go back to our AND 2, and we're going to choose that because that is actually part of our equation. So we'll choose the AND 2, and we'll say OK. And then we will add that to our user interface window. Okay. And it doesn't really matter where you've put it. I've sort of put it in the middle of the screen because I want to have some inputs on the left and I want to have some outputs on the right. I'll go ahead and press escape because I won't be adding any more ANDs. The other gate that I need is the NOT, and so I will scroll down and I can scroll down and find the NOT. You know, I could always have typed in here as well if there was one that I wanted. And so here's the NOT, and there it is, and we'll say OK. And I'm going to put that just to the left of this lower input. It doesn't matter which input it is associated with. The commutative property exists, as we know, for ANDs, and so it really doesn't matter. But I'll just arbitrarily choose to put it. And the same horizontal level as this lower and input. And again, I'll press escape to get rid of any additionals. If I wanted to add more knots to the circuit, I could just by continual to click where I wanted them. And so now that I have my NOT gate, I want to add some wires. There are lots of choices for wires. Notice we have several here. If we look at some of them, notice that this is actually thinner than these two. Okay, and so if we're just having a single wire, we want to choose the node tool. If we had multiple wires, we would choose a bus tool, and then for multiple buses, we would choose the conduit. Likewise, this is an orthogonal choice, and we also have a diagonal node tool, a diagonal bus tool, and a diagonal conduit tool. All right, so we're going to choose the diagonals. Either is fine. You can either choose the orthogonal node or the diagonal node. One of the TAs mentioned that he was having problems with using the orthogonal, so we'll just try the diagonal here. And so we're just going to place the pin coming out of the N2 and drawing a line to the knot to give us a wire between those. And I'll just press escape. And so we have that. Okay, and now I also want some inputs going into each of these that I'm going to attach to ports. And so I have the capability of doing a wire there. I see now it's set up as an orthogonal, and I'm going to actually come back and change that. I want to do the diagonal because I don't want to connect them. I'm going to press escape. I'm going to choose the diagonal node tool and just draw a wire up. And so I have two inputs, one going into this AND input and one going into the NOT. And pressing escape. And in case I'm concerned that it might not be connected, I can always move the end, and I see that the wire moves with it. And so I know that I do have good connections for all of those wires. I want to also go ahead and put a wire from the output of the AND, so I'll draw one more wire as well. And I'll click on the diagonal node tool and just draw one more wire. Okay, and length doesn't really matter, but I want to make sure that I can see it, so I'll make it and press escape to get rid of the opportunity to draw longer lines, because that one's plenty long enough. Okay, so once I have my wires, now I want to be able to connect these to a port. That's what we call input and outputs, are ports, and so I need two input ports and one output port. I'm going to go to the pin tool, and so I will click on the pin, and I'm going to use this arrow to pull down. I need two inputs, so I'm going to click on an input pin, and I'm going to attach that here. Oops, didn't attach. Move it up just a little bit. Let me just come down to this one. Then I'll move it. Okay, pressing escape. I want to move this one up, get it connected. Try to move it up. Sometimes we have to play a little bit and actually get it connected. And again, I can try and drag that out. Okay, and we also saw that this little name actually moved as well within there, but it's fine where it is. And so I have my two connections, and let me just make sure that this one is connected, and it is. As I pull it out, I don't see any separation between the wire and the pin, so that should be fine. And now I want to have an output pin, and so I'll choose the output pin and connect that to this output wire here. And so I have that, and let me press escape, and again just drag it out just a little bit to test, and that looks fine. Okay, and so I have my input and output pins connected to the wires. Okay, and so the next thing I want to do is assign names to these, and so the way I'm going to assign names is to click on the pin name right here. Okay, click that, double click it, and I'm going to use lowercase a. Okay, it's very important that you use lowercase. That's what's used in the test procedures, and so use lowercase a and lowercase b as assigned here. And likewise for the output, the name that was chosen was uppercase F. So make sure and use those names. Otherwise, when you try to run the test cases, it won't find the same names that you have associated with the inputs and outputs, and so therefore your test cases will fail. So use the names that are here. I will always try to use lowercase characters for inputs and uppercase characters for outputs for the names. But I'll try to be very clear for each lab. But for this lab, we have lowercase a, lowercase b, and the output is F, just like we did in lab 1. A ended with not B for F. Okay, now we can save by using the Control S shortcut, or we could use the save. I'm going to save this. I actually have lab 2, and so I will save this as my detector. Okay, .pdf. All right, and we have that, and I will save that. Okay, and I'm going to replace it because I am redoing this lab so that I can have a video for you. Okay, so now that we've saved that, we have created the schematic. Okay, we'll stop there.